Right. Hey everyone. So this is going to be the question 3 memory, and what it's going to do, it's going to take in a single input and it's going to print whether they saw that input exactly k function calls go. And if so, if it was like called k function calls go, it's going to print out found. Otherwise, it's going to print out not found, and it's going to keep on going. And so let's take a look at the doc test and see what happens here. So at the beginning, we call f equals 3 memory of first. So first is the first thing that we're putting into our memory, and that's like our function call, like right here. Like we're trying to see whether something was called k function calls go. Well, in the case of this problem, it's going to be 3 memory. So exactly 3 function calls go. So first, we have f of first, and it wasn't called 3 ago because we didn't call anything before, because there's like nothing before this first memory. And so we're going to print not found. Same with the second one. We never saw second anyways, so it's going to print not found. Third is going to print not found. And second, we saw second earlier, but at the same time, it was only called 2 function calls ago, so that's not going to count. And we're going to print not found. But then, when we see a second here, we're going to notice that it was called 3 function calls ago. And so we're going to print found. Same with third. 1, 2, 3. And then this third doesn't print out not found because, 3 function calls ago, we called it on the string second. And so yeah, keeping that in mind, let's dive into this problem. And so one thing I really want to point out with this is that we have f of first, f of second, and we're repeatedly calling this f function, which is going to return another f function that's going to go like f of second, f of third, and we can reuse this function over and over again. So that gives us the idea that it's probably going to be like self-reference. And what do we know about self-referential functions? It kind of has the format, like we have a outer function that's going to define an inner function, and the inner function is going to do things, and it's going to return a variation of like that function. And so what we notice is that we call 3 memory first, and that n is that first value, and then we're going to return f of none n. Well, let's think for a sec. So f is going to take in 3 parameters, x, y, z, and we're going to pass in the values none, n. And so why are we passing in the values of none and n, which is first? And what we can notice by kind of using our exam solving strategy is that x, y, and z, that's 3 parameters. And well, f is going to be like a 3 memory function. And what we know about self-referential functions is that the functions can contain some sort of memory, and that memory is contained within the parameters. So maybe the values x, y, z might be like the memory that we're trying to keep track of. And so since we inserted the n as the parameter to z, that might suggest that z is going to be the first, the most recent memory, and then y is going to be the second most recent memory, and x is going to be the last memory, the third memory that we actually care about checking. And so along with this, at the very end, the x memory is going to get thrown out because we kind of don't care whether something was called 4 function calls ago, 5 functions calls ago. And so once we hit the 3 and we passed 3 function calls ago, we don't care about it, so we can just discard that memory. So that's why we had the parameters x, y, and z. And then let's think about what this function will do. So it's going to either print not found or it's going to print found. So that means that somewhere in our code, we have to have print statements that say not found and found. And using our exam solving strategies, once again, let's take a look at the skeleton code. So if we notice, we only have 2 lines to fit this print statement because you can't really put it up here. Can't really put it in the return statement because we probably want to return something else. So it probably has to go in these 2 lines right here. So we're going to have to be printing something. It's either found or not found in one line and found and the other in the other line. So well, what is the if statement going to check? So if we notice, 3 memory of first is going to return f of none n. And it's going to be returning a variation of the g function maybe. Because the way higher self-referential functions are going to work is that maybe this f function is going to return some g function down below, like it's going to define g and it's going to return g, because if we don't, then there's no point in defining this g function. And then this g function is going to be used to call, like in this case, like f of second, we're going to be calling it on some like thing we want to store in the memory. And so what we're going to do here is that, let's say we pass in the number value second. So second is going to be assigned to I, and we're going to go like, maybe if we want to check if it was like equal to like the function call like three function calls ago. And our memory of 3 function calls ago is going to be what x is. And so if x is equal to whatever I is, then we want to print that it's found. So if x is equal to I, we're going to print found. But if it's not equal to I, then that means that it's not the same as exactly like k function calls ago. And so that means we're going to print not found. And then what do we want to return here? Well, with self-referential functions, we want to be able to call it over and over again. And so g of I is what we're going to be calling like all of these values on. So like f of second, f of third, like this f function is going to be an instance of this g function. And so what we want to do is we want to have some return statement that's going to evaluate to some instance of the g function. And well, what returns the g function, that's going to be the f function. And another like thing that might happen is the 3 memory function might also return an instance of the g function, because like 3 memory of n is going to call f on some values, which is going to return a g function. But what we want to remember is that xyz is going to be the memory. And instead of like shifting all the memories over, it's like the first memory goes to the second memory goes to the third memory, and the third memory gets discarded. What 3 memory of something is going to do is kind of going to get rid of everything. So it's going to get rid of the second and third memory and only insert the newest memory. So we don't really want to do that. We want to like shift it instead of like getting rid of some information. So that's why we want to have some call to f rather than 3 memory. And so what we want to return now is like our new memory that we want to hold. Because remember that these 3 parameters are going to be the memory that we're storing. And so, well, what we discussed was that we want to shift the memories over. So the x is going to get discarded. The y, the second memory, the old second memory is going to get moved to the third memory. The first is going to get moved to the second, so that's z. And then we want to insert our newest memory, because that's like our newest function call, and that value is going to be I. Because for example, if we call g on like maybe second, and it prints like not found, regardless, we want to like make second our most recent function call, our most recent memory. And so that's why we're going to pass in I for what z is. And yeah, that's pretty much what this function is. And just like an overview of like what happens, 3 memory of first is going to call f of none n, and that's like kind of initializing our memory. So we don't have like a second or third function call. That's why there's like 2 nuns here. And when we call g on something, like a certain value, we're going to check, is that equal to our third memory? So that's x, and that's going to be like 3 function calls ago. And so if it is, then great, we're going to print found, but otherwise we're going to print not found. And after that, we want to like adjust what our memory is. And so we're going to move our second to our third, our first memory to our second, and we're going to insert the newest memory, which is I, into like the first slot, which is what z is, the z parameter right here. And yeah, that's pretty much it. And make sure to email me if you have any questions. My email here is hatwang123@berkeley.edu. And yeah, have a great day.